Today we'll be looking at what it means to be independent in comparison to mutually exclusive within probability. We'll first look at independence, and then we'll look at mutually exclusive events and see that it is impossible for mutually exclusive events to be independent. Let's suppose we have a deck of cards. Within a deck of cards, we have different suits, different numbers. We have face cards, red and black cards. We're going to look at two different possible outcomes. Drawing a red card, we'll be looking at the probability of drawing a red card and drawing a face card. The probability of drawing a red card from the deck is 1 in 2, and the probability of drawing a face card is 3 to 13. What if I tell you that now we're only choosing a card from a pile of face cards? What is the probability of drawing a red card now? The probability of red given F is equal to 1/2. Did you notice anything? The probability of drawing a red card from a whole deck of cards was the same as the probability of drawing a red card from a deck of only face cards. So the probability of R is equal to the probability of R given F. Therefore, we can say that red cards and face cards are independent to one another. One way of checking for independence is as follows. The probability of A is equal to the probability of A given B. In our example, the probability of A is the probability of a red card, and the probability of A given B is the probability of a red card given its face card. As we saw, selecting from the entire deck and selecting from a pile of only face cards did not change the probability of selecting a red card. That is independence. Let's look at a few more probabilities from the same example. We saw that the probability of a red card was 1/2, the probability of face card was 3 in 13. So what is the probability of drawing a red face card? Or in other words, the probability of red card intersection face card? Well, it's 3 in 26. If we multiply the probability of red by the probability of F, we get 3 in 26 as well. This is not a coincidence. The red and face cards are independent. This shows us the second way of checking for independence in general. The general form for this method of checking for independence is the probability of A intersection B is equal to the probability of A multiplied by the probability of B. So how do we summarize independence? Well, two events are said to be independent of each other when the probability that one event occurs in no way affects the probability of the other event occurring. So what does mutually exclusive have to do with this? Well, mutually exclusive and independence are often confused with one another. I'm going to show you just how different they are and why a mutually exclusive event can never be independent. Let's have a look at our deck of cards again. This time, let's look at the probability of drawing a spade and the probability of drawing a heart. The probability of drawing a spade is 1 in 4, and the probability of drawing a heart is 1 in 4 as well. Earlier we learned that if two events are independent, then P of A is equal to P of A given B. Does the probability of spade equal to the probability of spade given heart? Definitely not. When selecting from the whole deck of cards, the probability of drawing a spade is 1 in 4. When drawing from a pile of hearts, which was the condition mentioned before, the probability of drawing a spade is 0, as it's absolutely impossible to draw a spade from a pile of hearts. Thus showing that these two events are not independent. We know that the probability of drawing a spade and drawing a heart are not independent events. They are, however, mutually exclusive. How do we know that, you may ask? Events or propositions are mutually exclusive if they cannot both be true. Additionally, you can check events are mutually exclusive using the following formula. Probability of A intersection B is equal to 0. Using what we have just learned about mutual exclusivity, let's investigate. The probability of drawing a heart and a spade is 0, as the probability of selecting a card that is both a heart and a spade is impossible. This leads us to one final reassurance that mutually exclusive and independent are very different. and that if two events are mutually exclusive, they cannot be independent. Earlier we learned that another check for independence is the probability of A intersection B is equal to the probability of A multiplied by probability of B. Let's see what happens with our hearts and spade example. Does the probability of H intersection S equal to the probability of H multiplied by the probability of S? Well, we know that probability of H intersection S is equal to 0, as it's impossible to have a heart and a spade. And probability of H multiplied by probability of S is equal to 1 over 16. 1 over 16 does not equal to 0. If events are independent, it means that knowing one event to be true does not impact the likelihood of the other. Where mutually exclusive events cannot be independent, as if we know one is true, it is impossible for the other to be true. Therefore, knowing one event to be true does have an impact on the likelihood of the other in the case of mutually exclusive events. Looking at our card example, knowing we were only picking from the face cards did not change the likelihood of selecting a heart, as the hearts and face cards were independent. As for selecting a spade given heart, you could only select one, as it was impossible to select a spade from a pile of hearts, as spades and hearts are mutually exclusive. Thank you for taking the time to watch. I hope it helps.